Before you install ADCS, a few key design decisions will shape everything that follows. In this topic, we'll decide which CA types you need, how many tiers your hierarchy should have, and how our Azure Lab models real enterprise PKI deployments. You've already seen how PKI works conceptually and built an Azure-based Active Directory lab to host it. Now we'll shift to design. What kind of certification authority you'll use, what role it plays, how the hierarchy is structured, and how policies are enforced. So you're ready to install Enterprise ADCS next. Think of PKI as the foundation of a building that every secure service will sit on. If that foundation is weak or poorly planned, you'll see cracks later as trust problems, messy administration, painful migrations, and real security gaps. Careful PKI design keeps future deployments simpler, safer, and aligned with business risk. Designing PKI starts with 4 decisions. First, define your audience. Are you issuing only to domain computers and web servers, or also to VPN users, mobile devices, and appliances? That drives scale and policy. Second, decide how enrollment works. Manual requests, automatic domain enrollment, or template-based issuance. Third, plan how you'll protect the root. Offline operation, hardware modules, and strict procedures. Finally, choose your CA architecture based on the isolation, availability, and administrative separation your organization requires. A standalone CA runs independently from Active Directory. It doesn't use domain templates or auto-enrollment, so every request is handled as a one-off decision. Admins manually verify who's asking, what certificate they need, and whether it matches policy, then approve or reject it. Because it's detached from daily domain traffic, this model is ideal for highly trusted offline root CAs or small isolated environments where tight manual control matters more than automation. An enterprise CA is tightly integrated with Active Directory, so it understands your users, groups, and computers. That integration lets you use certificate templates to define exactly who can request which types of certificates and under what conditions. Through group policy, you can then enable auto-enrollment so domain users and machines receive certificates automatically at scale. This makes enterprise CAs well-suited for large internal deployments, where consistency and automation are important. Standalone CAs act as highly controlled, mostly manual authorities. Because they don't rely on Active Directory, they're ideal as offline roots or in isolated environments where you want minimal exposure and deliberate approval of every certificate. Enterprise CAs sit at the other end of the spectrum, tightly integrated with AD, driven by certificate templates and auto-enrollment. They shine when you need consistent policies and large-scale routine issuance to domain users, computers, and services. Certificate templates are the blueprint for every certificate your enterprise CA issues. They define the certificate's purpose, which key usages are allowed, who appears in the subject name, and how long the certificate remains valid. Security permissions on the template decide which users or computers can enroll. Because templates live in Active Directory, the same rules apply everywhere in the domain, giving you consistent issuance and making template design a central security control. Manual issuance gives you tight control. Every request is reviewed, approved, and often tied to strong identity checks, which makes it ideal for high-value keys, admin accounts, or one-off scenarios. However, it doesn't scale and slows things down. Automated enrollment flips that trade-off. Group policy and templates push certificates everywhere with almost no manual effort. It's fast and scalable, but you now rely heavily on correct policy, permissions, and template design. The root CA is the ultimate trust anchor in a PKI. Everything below it, intermediate CAs, and all issued certificates, inherits its credibility. Systems explicitly trust the root by installing its certificate in a trusted root store, which is why the root is kept offline, heavily protected, and changed rarely. If an attacker compromises the root, every certificate in that hierarchy can become untrustworthy, effectively collapsing the entire PKI's security. A subordinate CA gets its authority from a parent CA, usually the root, and acts as the workhorse of the hierarchy. It's responsible for issuing and managing certificates for users, computers, servers, and services. In Microsoft environments, Enterprise issuing CAs integrate tightly with Active Directory templates and auto-enrollment. By keeping the root CA offline and using separate issuing CAs for daily operations, you gain strong security while still staying flexible and scalable. In Contoso's production PKI, the root CA is treated like a crown jewel. It's powered off most of the time, stored in a secure location, and never directly connected to the network. It wakes up only to sign new issuing CAs or publish updated CRLs, then goes dark again. Day-to-day enrollment is handled by online issuing CAs. This separation greatly limits attack paths, but it also demands disciplined procedures and careful change planning. CA hierarchies are all about trading simplicity for security and flexibility. A single-tier CA is easiest to run, but if it's compromised, everything is lost. A two-tier model adds an offline route that rarely changes, plus one or more online issuing CAs that handle day-to-day certificates. That's the most common design. A three-tier model inserts policy or intermediate CAs, giving large or regulated organizations fine-grained control at the cost of more servers and administration. For this course, we're trading some security realism for clarity and speed. We'll run everything from a single enterprise root CA so you can focus on the mechanics, integrating with Active Directory, configuring templates, handling enrollment, and practicing revocation and troubleshooting. In real production, you'd almost always separate duties with an offline root and one or more issuing CAs. Keep that distinction in mind as we work through the labs. Before you install ADCS, lock in 4 things. First, decide whether you need an enterprise CA with AD integration or a standalone CA for tighter isolation. Second, confirm your hierarchy, typically an offline route with online issuing CAs in production. Third, validate that your lab design matches the scenarios you'll practice. Once those decisions are in place, you're ready to start installing the enterprise CA.